This is lesson 10.9, translations. Trace a parallelogram-shaped pattern block onto a coordinate grid. Label the vertices A, B, C, D. Slide the pattern block over 5 units to the right and 2 units down. Trace the figure in its new position. Label the vertices A', B', C', D'. Trace the horizontal and vertical path between corresponding vertices. Let's do that. If I go from A to A', I'm going 5 to the right and 2 down. B to B', 5 to the right, 2 down. C to C', 5 to the right, 2 down. D to D', 5 to the right, 2 down. So every point moves the same direction and the same distance. Right 5, down 2. Now if I add 5 to each x-coordinate of the vertices of the original figure and subtract 2 from the y-coordinate of the vertices of the original figure, what I will get is the same thing, because adding 5 to my x-coordinate means 5 right. Subtracting 2 from my y-coordinate means 2 down. A transformation maps one figure onto another. When you move the figure without turning it, the motion is called a translation. Move the figure without turning it. When translating a figure, every point of the original figure is moved the same distance and in the same direction, and you can see that right here. Translate quadrilateral HIJK, 2 units left and 5 units up. Graph quadrilateral H', I', J', K'. And again, you can see, if we go here, if we go from H to H', we're going 2 to the left and up 5. I', 2 to the left, up 5. K to K', 2 to the left, up 5. And J to J', 2 to the left, up 5. So what that means is, by going 2 to the left, I'm subtracting 2 from my x value, and going up 5 means I'm adding 5 to my y value in each of the coordinates. Translate quadrilateral HIJK, 4 units up and 2 units right. Graph H', I', J', K'. And I've done that already to save a little time. I've already graphed the 2 images. And again, they want me to go up 4 and 2 right. So if I go H, I'm going up 4, 2 right. I goes up 4 and 2 right. J, up 4, 2 right. K, up 4 and 2 right. What that means again is I'm adding 2 to my x value and I'm adding 4 to my y value. And you can see that in the ordered pairs here. If we just look at H, for example, I go from -4 to -2, which means I've added 2. If I go from 1 to 5, that means that's my y value. This is x. This is y. That means I've gone from 1 to 5. Means I've added 4 to every point, every vertex of the original quadrilateral. When a figure has been translated, the original figure and the translated figure or image are congruent. Congruent figures have the same size and same shape, and the corresponding sides and angles have equal measure. You can increase or decrease the coordinates of the vertices of a figure by a fixed amount to find the coordinates of the translated vertices. A positive integer describes a translation right or up. Right if it's x, up if it's y. A negative integer describes a translation left or down. left if it's x, down if it's y. Triangle LMN has vertices -1, 2, 6, -3, and 2, -5. Find the vertices of L prime, M prime, N prime after a translation of 6 units left and 4 units up. So what that means is I'm going to add a -6 to my x value and a +4 to my y value because I'm going left and up. Left is negative for x, up is positive for y. So you can see what's happened here. And again, I'll just do 1 or 2. If I go from n to n prime, I'm going where? Six to the left and up 4. L to L prime, 6 to the left, up 4. Okay? Triangle TUV has vertices 6, -3, -2, 0, and -1, 2. Find the vertices of T prime, U prime, V prime after a translation of 3 units right and 4 units down. And I've done that here. Here's triangle TUV in the green and triangle T prime, U prime, V prime in the blue. And what I've done is I've moved my x coordinate 3 units to the right and my y coordinate 4 units down. I've added 3, as you can see here, to the x value, and I've added a -3 to the y value. And so if I do just a couple here, you can see that from V to V prime, I'm going 2 right. Actually, it's 3 right and 4 down. U to U prime, 3 right, 4 down. T to T prime, 3 right, 4 down. We're going to skip down here to problem number 2. We're going to translate quadrilateral DEFG, which has vertices 1, 0, -2, -2, 2, 4, and 6, -3. You can see I've already done that here. It says 4 right and 5 down. Okay, so these are the ordered pairs of my original figure. These are the coordinates of my image. So what I've done again is with 4 right and 5 down means I've gone with my x value 4 to the right and with my y value 5 down, and I've done that for every vertex. 4 right, and 5 down, 4 right, and 5 down. And you can see from here, in my ordered pairs, I've added 4 to the x value, I've subtracted 5 from the y value. You can see that in every single example. Lesson 10:10. I'm going to do these 2 lessons together, is reflections. It says, scientists have determined that the human eye sees symmetry, uses symmetry to see. It is possible to understand what you are looking at, even if you don't see all of it. The top half of the words at the right are missing. Identify the words. Fairly obviously, this is box, this is code. And you can see that what I've done here is I've actually copied these and flipped them. And with a little bit of adjustment here, you can see that they clearly are box and code. It says, list all the capital letters of the alphabet that when folded across a horizontal line look exactly the same. I've done that down here. I've listed all the letters of the alphabet. If I go through and see which ones look exactly the same, I would have B, I would have C, I would have D, I would have E, I would have H, I, O, X, I believe, and X. So not all, not very many actually. On a piece of paper, write the bottom half of each word that, when reflected across a horizontal line, looks exactly the same. Well, I didn't do that, but I wrote some words. You can see that bed, hide, and ox, I can actually, if I want to, draw a horizontal line through those, and they will reflect. Real world examples. Determine whether each figure has line symmetry. If so, copy the figure and draw its line of symmetry. You can see that E has a horizontal line of symmetry, G has none, H has horizontal and vertical. In my examples, in my square I have a horizontal, I have a vertical, and I actually have two diagonals like this. True only in a square. In my regular pentagon I have a vertical, and in this pentagon, 1, 2, 3, 4, 5, I have none. A reflection is a mirror image of the original figure. It is the result of a transformation of a figure over a line called a line of reflection. Reflect a figure over the x-axis. That's my horizontal axis. Triangle ABC has vertices 5, 2, 1, 3, and negative 1, 1. Graph the figure and its reflected image over the x-axis, then find the coordinates of the vertices of the reflected image. Now, what you can see here that's different than what we did before is there is no movement horizontally for each of the points. They move vertically, but not horizontally. What I've done is flip them here. The coordinates now are 5, negative 2, 1, negative 3, and negative 1, 1. And you can see in the example down here more clearly what I mean. What I've done here is I've graphed rectangle, GHIJ. These are the coordinates of that right here. And then I've reflected it. Notice that I and I prime have moved only vertically. Same with H and H prime, G and G prime, J and J prime. Now, you can see it more clearly when you go to the ordered pairs. Notice here that all of the x values remain the same. What's different is the y values have become the opposite of the previous y values. So what I've got is negative 4, and 4. Those numbers are opposites. I've got negative 1 and 1. I've got 1 and negative 1. And I've got negative 4 and 4. So the y value, x values have stayed the same. The y values have been changed to the opposite, which gives me a reflection over the x-axis. Reflecting a figure over the y-axis. I'm going to graph quadrilateral KLMN with vertices 2, 3, 5, 1, 4, negative 2, and 1, negative 1. Graph the figure and its reflected image over the y-axis. The blue image is my original image. The green is my reflection. K prime, L prime, M prime, M prime. These are the coordinates of that figure. And again, if I go down to this example, you can see it a little better. I've graphed triangle PQR right here, PQR, and I've graphed the triangle P prime, Q prime, R prime. And what you'll notice here, now because I'm reflecting over the y-axis, which is my vertical axis, is that the y values remain the same. And the x values become the opposites. These are the x's. These are the y's. So P is 1. P prime is negative 1. The y value is 5 in both cases. Q is 3. Q prime is negative 3. Again, the y value remains 7. The r value is 5. The x value of the r vertice is 5. The x value of the reflection is negative 5, or the opposite. Again, y value stays the same. Determine whether each figure has line symmetry. If so, copy the figure and draw all lines of symmetry. This is one of the trickier ones that you'll see. This is a parallelogram. It does not have a line of symmetry. Students think that this one is, but if you fold it in two, it's not. It does not have a line of symmetry. This appears to be a regular hexagon Should have one like this, should have one like this, should have one through here, one through here. So 1, 2, 3, 4 lines of symmetry. This one has a horizontal one, or a vertical one, I'm sorry, and no horizontal. We're going to skip down, and we're going to do number 5. We're going to graph the triangle ABC. Coordinates 5, 8, 1, 2, 6, 4. We're going to reflect it across the x-axis. So what we do is we keep the same x value. This is the x value. And we take the opposite of the y value. So B becomes 5, negative 8 from 5, 8. Or excuse me, A becomes negative 5, negative 8 from 5, 8 to 5, negative 8. B becomes from 1, 2 to 1, negative 2. And C from 6, 4 to 6, negative 4. So again, in this case, because I'm reflecting over the x-axis, the x value remains the same. The y value becomes the opposite. Here's your vocabulary for this lesson. 1, 2, 3, 4, 5, 6, 7. Should know those, should memorize them, put them in your notable, study them for the Chapter 10 vocabulary test. At this point, you should quit watching the video. Go log into Naiku at www.naiku.net. Log in with your username and password and take the lesson 9. I believe it says lesson quiz 10-9, but it's actually a combination of the two. Thank you.